Hello dear students, this is a question from mathematics paper. I'll write the code here, which is 970942 October November 2024 paper. So question number 4, and here you can see that we have two questions, A and B, and we have two blocks or two masses, A and B, that is connected with strings, okay, inextensible strings, from P to A, from A to B, B to Q. Okay, so this angle, okay, with this string is 45 degrees, and this angle with this string is theta degrees. Okay, so here the weight will act like that. Okay, both the weights will act like that, and tension will be acting in these two wires. Also the tension will be acting in these two wires. First, let me draw the free body diagram of A and B. Okay, down, and we have to find what values of tension in AB. So AB, here what is the tension, and values of the value of this theta, and what is the tension in BQ. They're asking, they didn't ask what is the tension in AP. Okay, but if they ask, we can easily find that also. So let's see how to do this question. Okay, first we'll draw the free body diagram of A. So assume that this is the particle A I have. Okay, its weight will be towards down, that will be 2 newtons, right? Okay, so here B will just have a tension with A, so let's put that as T2. Okay, T2, and one more tension will be from P, that will be T1. And they said this angle, okay, this angle is 45 degrees, so this angle will also be 45 degrees, right? So this is also 45 degrees. So T1 I can resolve into two components, that is, one is upwards, that is T1 sine 45 degrees, and T1 cos 45 degrees. We have to find tension in AB. Okay, so AB means this T2 only we have to find. Okay, basically T2 is here in this AB. So T2 is actually equal to T1 cos 45, or T1 cos 45 and sin 45 are equal, so I can write T2 is equals to T1 sin 45. Sin 45, sin 45 also I can, because both have same values. So T1 sin 45 is equals to 2. Okay, 2 newtons. So T2 will be equal to just 2 newtons. So we found what is the answer for A. Now the interesting part is what is the answer for B1. Okay, what is the answer for B1? So in that we have to find the theta, we have to find the tension here. So let's do that. So for B also I'm drawing a free body diagram. Okay, so let's draw the free body diagram for B. So I will take a different pen for that. So this is actually A, and B I'm drawing it here. Okay, B, this is B, and yeah, so now, so the mass of B is 0.1 kg. Okay, so the mass of B is 0.1 kg, so 1 newtons will be here, and there will be T2 here, this side the T2 will be there. Okay, and then there will be a T3 tension here, so that is theta angle to the horizontal, right? So this is actually theta degrees. So T3 I can resolve into two components, so this will be T3 cos theta, and this will be T3 sin theta. I need to find theta in T3. I need to find. So now T3 sin theta is equal to 1 newtons, and T3 cos theta is equals to T2. T2 already we found, which is 2. Okay, let's take this is equation 1 and this is equation 2. So 1 divided by 2 if I do, okay, 1 divided by 2 if I do, I'll be getting T3 will go off, sin by cos will be tan theta, that is equal to 1 by 2. So theta if you calculate, that will be simply tan inverse of 1 by 2, and theta will be equal to 26.6 degrees. So now if you plug the theta in any one of the value, let's take this one, okay, the first equation, T3 sine 26.6, that is equal to 1. So T3 is equals to 1 by sine of 26.6 degrees, that will be equal to 2.24 newtons. So T3 value, that is tension force, okay, in that wire will be 2.24 newtons, and theta value is 26.6 newtons. So this question is also over for 4 marks. So theta is 26.6, and the tension here, that is T3 will be, or tension in BQ will be, that's what they're asking, BQ, that will be 2.24. and what is the tension between A and B? Is it's simply 2. Hope this explanation helps you in understanding, students. Thank you.